Hi, my name is Zangbo, and today I'm going to talk about the design of experiment that will be full factorial design and fractional factorial design in statistics. So the contents of my presentation is introduction, and then about the full factorial design. Then part 2 would be fractional factorial design, and I would also be making the comparison of the designs and making the conclusions. So what is basically design of the experiment? So it is a statistical structured approach for the planning, conducting, and analyzing of the experiments. And from this design of experiment, we can also understand the various impact of the input factors, and we will be able to identify the influential factors, and we will be able to also optimize process by changing the inputs. So key concepts will also be used, such as factors response, the control of the experiments, statistical analysis. And the purpose of design of the experiment is basically, as I have already mentioned, optimize the processes and identify significant factors. Then we can see what are the effect of the interactions and do the proper analysis for informed decision making. And for the full factorial design, we have main and interaction effects, and through this high level main interaction plot, we can understand that with the highest slope, it will have the maximum impact, and with the lower slopes, it will have lesser impact. And for this design of experiment, we will consider the excess flash values which is provided, and then consider two levels, high and low, and consider four factors, A, B, C, D, which is pressure, time, speed, and the rotational speed of the screw. And coming to the full factorial design, it is for the four factors, it is called 4 raised to the power 4, and for this we will have 16 columns and rows, and the main factors A, B, C, D, and interaction factors, the combination of the main factors can be put in columns and rows as shown in the table. From this full factorial design, what we can do is we can do the regression analysis or ANOVA analysis, and then find out the normal probability plot, and plot the normal probability with respect to effect. By doing so, what we can understand from this plot is that the points or the factors which are further away from the normal distribution plot will have the highest impact, whereas the points which are having which are actually nearer to the distribution plot will have lesser impact. And here the furthest away is C, which is actually speed. So for the main interaction, we can also plot the main and interaction, and then understand their interactions, and from these also the highest slope will have maximum impact, whereas lower slope will have lesser impact. So we can understand the factors which are impacting more and less. Full factorial design can also be reduced, understanding the ones which are not making impact can be ignored. And for this, from the experiment, we have understood that the maximum order combinations or the interactions will have lesser impact, and the main factors will have higher impact. and of course its combination can also have the effect, but normally the higher orders have lesser impact. So that way higher orders can be neglected and we can reduce the matrix as given in the table. So we can do ANOVA and regression analysis. From the ANOVA we can calculate those GF, SS, MS and significance F. And from the regression analysis, one of the important factors that we get is coefficients, that is the effect, and values of P. From these values of P, we can say that those factors which are lesser than 95% confidence interval level are impactful, and those which are higher than 95% CI are not impacting the output. So that way we can neglect the ones which are above the 95% confidence interval level. So from the regression analysis, one of the important things that we can calculate is the prediction model, and the values of effect, whatever we get from the regression model, can be fit into this prediction model. And this prediction model, in comparison, if you compare with the original values, then we can get the residues. So this prediction value and the original value will have the residues which we can calculate and then plot it either with probability plot or the effects. And from this residual value plot, we can understand that the residues which are equally distributed above and below are good for the analysis, and if the residues are only on the one side or further away from the probability plot, then the considerations whatever we are making for these factors are not good. We need to do further analysis or optimization. So coming to the fractional design, we can reduce the factors by two methods, that is half fractional design and quarter fractional design. And for the half fractional design, we can consider the highest interaction, that is ABCD, and then reduce the columns and rows. So one of the things that we get from these fractional designs are the aliases, and the aliases are the ones which are having the identical values or the factors or the labels inside, and those will have the same effect. So that way we need to identify and then remove one of them, or the ones which are having the similar effects. So for these half fractional design, the aliases we can see A is aliased with BCD and B is aliased with ACD. Likewise, C and other combinations are also available. And for the quarter fractional design, we consider two interactions, basically ACD and BCD, the higher orders. And from these we can also calculate the aliases like the one which is done in half factorial design. And similar to the full factorial design, we can do ANOVA test, regression analysis and prediction model, and do the adequacy test through residuals. Comparing the two designs, full designs and the fractional design, full factorial designs consider all the factors, whereas for the fractional design we optimize the factors by eliminating the least impacting factors, and more resources, and it requires more time to do the computation for the full factorial, whereas because of the decrease in the factors, it takes lesser computation time and cost and lesser resources for the fractional design. And full factorial designs can provide the complete information because of consideration of all the factors, whereas the fractional design may not provide complete information, especially the higher orders, because of the aliases or um, neglecting of those higher order ones. And coming to the resolution, because of the aliases, the fractional design will have lesser resolution, and of course because of this aliases it becomes a little bit more complex to find out the aliases and then do optimization, whereas it is simple for this full factorial design. So considering these factors, I can definitely say that while uh, fractional design reduces the computation cost, but there are more advantages in the full factorial design, and full factorial design is better. With this, I would like to thank you for your patience.